In this lesson, we're going to talk about elimination reactions. So remember, organic reactions are when we take smaller, more simple organic reactions to create larger, more complex ones like Taxol, which is an anti-cancer drug. So the different types of reactions we are going to talk about listed here, and we're going to focus on elimination today. So elimination reactions remove a molecule from a larger molecule, and that is going to form either a double or a triple bond. So they're the opposite or the reverse of addition reactions. So here one reactant is going to break up to give two products. So a smaller molecule and then an alkene or an alkyne. So alcohols can undergo elimination if there is a strong acid present as a catalyst and if that is heated as well. Alkyl elimination to produce alkenes. So we have whatever alkane with the molecule that is going to be removed, and then there's going to be a double bond created between those two carbons, as there's a bond created between those two pairs that were attached to a carbon in an elimination reaction. So there's our general equation. So if I have propane 2-ol, and we're in the presence of the catalyst, the strong acid, and that is heated. So the hydroxide there is going to pair with one of the hydrogens on either side of it. And so that is going to create a double bond, and in this case, the pairing was actually over here. So then a double bond was created between that. So hydrogen and hydroxide come together to form water as the small molecule that is removed. So if we have an asymmetric molecule, so in the example we just looked at, it didn't really matter which side we drew it on. The naming was going to be the exact same. So here we have 2-bromobutane. So we've got the bromine over here. So the question is that going to pair with that hydrogen or that hydrogen for HBr to get removed? And so is the double bond going to be between these two carbons or those two carbons? So the general rule here is that the hydrogen is more likely to get removed from a carbon that has the most carbon-carbon bonds. So this hydrogen is attached to a carbon that is only attached to one carbon. This hydrogen is attached to a carbon that is attached to two carbons. So this is the hydrogen most likely to be removed. So this is kind of the reverse of Markovnikov's rule. So where is the hydrogen going to come from? And then that means that our major product, so more of what gets created, is going to have the double bond between the second and third carbons. So that's going to be but2-ene, and then we have also but1-ene as the minor product. So this part here you don't need to worry about here. There's going to be a reaction with this as well, but we for now are just going to write HBr as what gets removed here.